this assessment, we're asked to show the mechanism of the dehydration reaction of a primary amide to make a nitrile. Now we're using this reagent we haven't seen before, and the mechanism is going to be something new, but let's think about the information we know to help us write this mechanism. The first is that the oxygen-phosphorus bond is very strong. So anytime we see a reagent that has phosphorus in it, we want to think about forming a new oxygen-phosphorus bond. That is often going to be the driving force for reactions involving reagents with phosphorus in them. The other thing we can get from the reaction itself is to note that what has been added to this reagent. And what you notice is that we've added a new OH and another H. We've added OH2, which is essentially water. So as we write this mechanism, we want to think about how this amide can lose one oxygen and two hydrogens, essentially a molecule of water. So with those two pieces of information in mind, we're ready to draw the mechanism. The mechanism is going to start by oxygen, again, attacking that phosphorus. We show it that way. It's going to push the electrons onto the oxygen. So I'm a little off on the screen, but that should be okay. Let's draw the product that gives us. This is the product that we would get. Now, this positive charge on oxygen can be stabilized by resonance with the nitrogen. If we look at where that gets us, it forms the first nitrogen-carbon pi bond. So in the nitrile, we're going to have a triple bond, a single bond, or sigma bond, and two pi bonds. We've now formed one of the pi bonds. We've also added a new oxygen to phosphorus, which is something we knew we were going to have to do at some point. If we look at this molecule and think about how this molecule could be more stable, we've got a negative charge on oxygen and a positive charge on the nitrogen. These protons are both going to be acidic. So in the next step, we can show the transfer of a proton from the nitrogen to the oxygen. Our product over here tells us that that was going to happen because we knew that one of the oxygens was going to have to pick up a proton. Let's draw the molecule that gives us. As we said with that molecule, we now have added a second pi bond, or a second bond, a first pi bond, and we've added a proton to one of the oxygens on that phosphorus. The next thing that's going to happen, we need to form a second pi bond. We need to form the third bond, the third carbon-nitrogen bond. We can do that by using this lone pair on nitrogen to collapse down and kick out this as a leaving group. Now we're going to run out of space here, so let me write the product of this first step. This is going to be the essentially a protonated nitrile. Make sure I don't run out of space. There we go. Barely fit that in. That'll have a positive charge on nitrogen. What's the other group that we're going to make? This phosphate, this diphosphate that we have here. Let me draw that in this position. So in this step, what we could think of as an elimination, or what looks like an elimination reaction, this lone pair collapsing to kick out the good leaving group, we've created a molecule that has a negative charge, and we've created a molecule with a positive charge on nitrogen. This proton is acidic. This is basic. We can protonate that oxygen. This oxygen grabs that proton to give us this. That's going to complete formation of the phosphorus reagent and our nitrile. This is the mechanism of the dehydration reaction.